I'm going to tell you how to write a good test specification. Hi, I'm Daryl Frank. I'm a principal systems engineer with over 25 years experience in military aircraft weapon systems integration and certification. I even wrote a book called Requirements to Reality to explain this exact mystery. Writing good test specifications is one of those things that can make or break a project. Done well, it proves compliance, keeps certification engineers happy, and makes life easier for the poor soul who actually has to run the test. Done badly, well, let's say it leads to confusion, wasted hours, and sometimes even dangerous situations. Every test spec starts at the same place, the requirements. The requirement defines what we're trying to prove, so the very first section of your spec is to define the objective. Don't waffle, don't get vague, just answer the question. What are we trying to prove? If your test covers multiple requirements, then create a table which clearly defines which requirements are addressed in this test specification. Make sure the reference is clear so that it can be properly linked in the compliance matrix. Next, the expected result. The expected results are defined for each test defined within the test specification. Think of it as, what does success look like and how do I know when the test is over from a tester's point of view? These are also known as exit criteria. When do you stop testing? Be clear and measurable. If the requirement says the system shall boot within 30 seconds, your expected result shall look for that. But what if the system doesn't boot within 30 seconds? Maybe 60 seconds to characterize for partial compliance? Or do we accept a fail and stop immediately at 31 seconds? In most cases, the expected result will be a repetition of the requirement. However, sometimes the proof of the requirement is embedded within the test result and the test pass or fail criteria may not be observable to the tester and will only be determined later, for example, where test data must be analyzed before a pass or fail can be declared. This one is huge. You need crystal clear pass-fail criteria. Not the system should work okay, but something measurable and decisive. And if the test fails, we define how the failure will be characterized. Sometimes you will have a partial compliance or need a concession or trigger a design review. The test spec should guide the test report so there's enough information to make decisions later. The pass-fail criteria should define what the data analysis should be looking for, and the final result may only be in the test report. The preconditions and setup are where you paint the full picture of what the test environment should look like. What needs to be ready, what's in the setup. Include drawings, diagrams, part numbers, parts lists, software configurations, the whole lot. The goal is that anyone can pick up the spec and recreate the setup without guesswork. Don't forget to include in the preconditions details like which menu must be selected in the software being used, or what setting must be selected on the signal generator. These can be included in the test procedure, but it's usually better practice to include anything that can be set up beforehand in the preconditions. The test procedure is the step-by-step test recipe, written for someone with zero experience of the system. I've been on projects where certification engineers have had to review specs without knowing the system at all. And towards the end of the project, when the hockey stick effect kicks in, you might have engineers parachuted in from other teams to assist with testing. Be ultra-specific. I often use phrases like shift focus to the oscilloscope, set volts per division to 1 volt so that the tester knows exactly where to focus attention on a particular test step. Don't be afraid to include diagrams and photos, the clearer the better. For example, if your requirement is the equipment shall be compliant with the vibration requirements detailed in method 514 of MIL Standard 810, that's not enough to define the test specification. Ensure you go through in detail through the standard and ensure the specific tests applicable to your project are specified in your test spec, so that time and money are not wasted on unnecessary testing. And now safety and risk assessment. It's often overlooked, but in the early development, the final product safety features aren't usually in place yet. That means that your test is riskier than the final system in service. Your test specification should include a risk assessment. Identify hazards, define what protective measures are needed for the specific test, and call out required system protection, PPE, barriers or precaution. Never assume common sense or standard practice is enough. Write it down. At the end of the day, no test is worth an injury, damaged hardware, or even worse, ending a career because safety was left out. Finally, create a test card. This goes in the appendix and mirrors the procedure in a simple tick box style. The tester can fill in values, tick off steps, and the test card becomes the foundation for the test report. Don't forget to include proper recording of the personnel, the configuration of all test equipment and the software. That way the test report captures the exact setup used. So to recap, start with the requirement, define the objective, exit criteria, pass-fail criteria, setup, detailed procedure, safety considerations, and a test card. If you do all of that, you'll have a test specification that's clear, auditable, and usable by anyone, whether they're the lead systems engineer or someone drafted in at the last minute. Got stories of bad test specs you've seen? Drop them in the comments. Maybe I'll do a follow-up video on the worst offenders. And if you found this helpful, hit like and subscribe and share it with your fellow engineers. Until next time, keep it systematic. Check the description for the link to my book, Requirements to Reality, which explains systems engineering in simple language.